Okay, so we're getting started here with just some really basic conversions of various kinds of units that you're going to see in chemistry problems that we'll do in AP Chem. There's a few places where you have to go Celsius to Kelvin in temperature scale. We don't use Fahrenheit really anything in science, and we don't use it in AP either. That might be one you haven't done as much of with Celsius and Kelvin. You might be familiar with it. You might be less. We'll see here in just a minute. The second page of these is conversions involving pressure. So gas laws, collecting and studying gases and gas behaviors. We measure their pressure, and there are three different units mainly that are used in AP problems. There are lots of other pressure units, but we only use three in our AP problems. And then the last page has to do with mass and volume conversions. So involving masses, grams, kilograms, and milligrams, and then liters and milliliters. Those are really the common usages of masses and volumes. So just to kind of point out, there is an equation on your formula sheet that you should have that will reference this for you. And the equation will talk to you about how to convert between Celsius and Kelvin in case you haven't used that one before. So Kelvin temperatures are simply the same as Celsius plus an adjustment of 273. So Kelvins are always much larger than Celsius, because we always add 273 to any Celsius temperature. And then, of course, I don't want to insult your intelligence, but the reverse of that, of course, Celsius would be Kelvin minus 273. Now, you might learn that Kelvin and Celsius are related by 273.15 or a decimal along that line. This is good enough for our work here. So 273 can be the adjustment factor. Kelvin is never negative. 0 Kelvin's the coldest temperature we can get to. And so as we get to our Kelvin temperatures, notice you'll never see negatives, but you will see plenty of negative Celsius temperatures. So Kelvin is Celsius plus 273. So question number one, right out of the gates here. 45 Celsius, convert that to Kelvin. Well, easy enough. 45 Celsius plus 273, right, gives us the Kelvin temperature. So go to your calculator, add that up, 45 plus 273. If you can do that in your head, super. If you want to double check it, you'll always be able to have a calculator on your longer problems. But to be able to do that kind of math on paper, if you have to check it, or just in your head, is good, because on multiple choice questions, you don't have a calculator. So this is 318 Kelvin. Simple as that. To get from Kelvin back to Celsius, we do just the opposite. So on number 2, 333 Kelvin minus 273 would give us our Celsius temp. And that's, hopefully you can do that one in your head or on paper. That one's going to be 60 Celsius. So 60 degrees Celsius. Kelvin, notice, doesn't have a degree symbol. Celsius and Fahrenheit both have a degree symbol on them. Kelvin doesn't need that. You don't need to understand why. Kelvins are the unit. They're not degrees Kelvin. It's just Kelvins. That's really just semantics. So it's not something that you have to worry about. If you accidentally wrote degrees Kelvin, I don't think you're ever going to lose credit for that anywhere. Just one more on number 3. With Celsius to Kelvin, since we have negative 125, so negative 125 Celsius plus 273, always adding on to Celsius to get to Kelvin. So with that one, maybe in your head it's a little bit trickier, maybe it's not. I do a lot of these in my head pretty routinely, but I don't always like to assume that students can. So go ahead and punch it in your calculator if you want to. Negative 125 plus 273 gives us a positive Kelvin temperature of 148 Kelvins. Okay, something like that. And then we'll do just one more, just to go back the other way again. Number 5 asks us to do 98 Kelvin into Celsius. So 98 Kelvin minus it's not 298, minus 273 equals a Celsius temperature. So 98 minus 273 going to give us a very negative 175 Celsius. Okay, so something like that. So just these two equations again right here. Oops. These two equations, Celsius to Kelvin and Kelvin to Celsius, it's listed on your formula sheet. So you don't have to memorize 273. You just have to be able to use it. There are lots of problems where you'll have to work with Kelvin in gas laws, or if you're given Celsius, which is fairly common because thermometers are always in Celsius. So to collect data in Celsius is realistic and common. but you'll need to get into Kelvin in order to use that temperature in most of our gas laws. So for now, the only real purpose of this is to get you converting back and forth comfortably, so that when we use those in bigger problems later, you'll have a good grasp of that. So that's all I'll do on that page. The second page, again, has to do with pressure units. So on your formula page, we're going to find the pressure relationships, so you can see where those are listed on your formulas page. So if you don't have your formulas page in front of you, pull that out, and I'll show them to you here on the screen as well. So if you look over here on your formula sheet, I've got it here on the screen. This is on the back side of your formulas page. So again, I'm looking at this main AP equations and constants page, which is formulas page. On the back side of it is the section on gases, liquids, and solutions. So there are a few gas laws along with some pressure units that we're going to use. So I'm just going to draw your attention for now anyway to this part here on the back. 1 atmosphere is equal to 760 millimeters of mercury and is equal to 760 torr. So a millimeter of mercury and torr is exactly the same thing. It also says here that standard temperature and pressure. Okay, you don't see it listed as that, but standard temperature and pressure is STP. That's equal to 1 atmosphere. So each of these, any one of these three, is standard temperature and pressure. 1 atmosphere is listed there, 760 millimeters of mercury, 760 torr. Those are all considered standard pressure, and they're all interchangeable or equivalents to each other. Okay, so $1 is equal to 4 quarters is equal to 100 pennies. They're all equivalent statements. So we can work with those as ways of getting between the units, converting between the units, just like you would to convert inches to feet, for example, or anything else. So let's just take a quick look at some of these pressure units with these equalities in mind, just so we don't have to go back and forth. I'm just going to jot them on top of the page here so that we have them handy. Okay, so 1 atmosphere is equal to 760 millimeters of mercury, and is equal to what's called 760 torr, which is named after someone with a much longer last name than Torr. So 760 millimeters of mercury is a pressure unit. We haven't talked to you about it all here, how that was derived or where that comes from. So for now, don't worry about that. You can always learn about that later. But 760 millimeters of mercury and 1 atmosphere are interchangeable, as is the equivalence in torr. So to do a conversion here is really quick and easy. We're going to start with the pressure unit that we have, 445 millimeters of mercury. And then you just need to find an equivalent statement that relates millimeters of mercury to atmospheres, since that's what they're wanting us to do. Convert millimeters of mercury into atmospheres. So we need an equality statement that's going to do that. And you're going to see me talk a lot about these equality statements or conversion factors. I sometimes call them truths. In first-year chemistry, just things that are true that you can use to relate one thing to another. Well, we have one. It's right up here at the top of the page, right? 1 atmosphere is equal to 760 millimeters of mercury. That's what we're going to use. Now, how you show that is up to you. I know a lot of Algebra 2 folks come in familiar with setting it up something like that, except they can draw a straight line, which apparently I can't do. And they use their conversion factors that way. So they would say that 1 atmosphere is equal to 760 millimeters of mercury. I'm going to guess most of you have had Algebra 2. It's something that you learn and you're familiar with. This is going to be old hat and really easy for you, and that's great. That's where we want you to be. If you're not, really all I'm saying here is that whatever goes above this line and below this line, those are equivalents to each other. So 45 is a mercury beginning number, and then in this space, okay, right in here, I'm putting an equivalence or an equality statement. 1 atmosphere of pressure is equal to 760 millimeters of mercury of pressure. And you can put anything you want in those two boxes, top and bottom, as long as they're true and equal to each other. 1 atmosphere is equal to 760 millimeters of mercury. It's right there on my formula sheet. So any truth statement, as I call them, can go in there, whatever's useful to you. But the one that we wanted here is the one we put in. And the reason this is the one we would choose is because this will help us cancel the units, because millimeters of mercury will cancel as our unit, and that'll leave us with just atmospheres of pressure as our answer. So to punch that in my calculator, it's 45 times 1, which you don't really need to do, right? And then divided by whatever numbers are on the bottom, 760. So I can punch the whole thing in, 45 times 1. Oops. And again, you wouldn't need to punch in times 1. With 45 times 1, you can do that. Divided by 760. And that gives us an answer here of 0.0592. Okay. As far as units go, okay, as far as rounding goes, if you haven't learned about significant figures, you're going to hear me refer to significant figures, and we'll be hammering on that as the school year goes on, and you'll have to get comfortable with making those conversions. But in this case, I'm going to round my answer so that it has two significant figures because my original pressure had two significant figures. And again, if you don't know what that is, just write down the rounding that I do, and then later on you can fill in the blanks on how to round yourself. It's not hard. You're going to figure it right out. So I want my answer to have two significant figures. I would write it as 0.059. Those are my two significant figures to match the two significance that I had in my original pressure. So rounding is the key here. That maybe is new to you if you're not comfortable with significant figures. And then my units will be at atmospheres. So it goes right there. 0.059 atmospheres of pressure. So we made our quick conversion, again, from millimeters of mercury to atmospheres simply by finding a way to link those two using an equality statement or a truth statement. Okay, let's do one more. 24 torr, this is number 2 on the same page. 29.4 torr is how many atmospheres? Again, we're going to go back up to our equalities at the top of the page, and I'm going to use a different one this time. I'm going to say that 1 atmosphere is equal to 760 torr. Okay, so torr in millimeters of mercury, again, the same, and interchangeable. So again, 1 atmosphere is equal to 760 torr. And that torr out. This is an equality statement. 1 atmosphere equals 760 torr. So I can put that in there and use it. And I punch that in my calculator, 29.4 divided by 760. Again, you can leave the times 1 out because, of course, that doesn't matter. So 29.4 divided by 760 gives me an answer of 0.03868, blah, blah, blah. Again, we're going to round that off because 29.4 has 3 digits in it that are significant. My answer should too, so I'm going to round that off to 0.0387 atmospheres. Boom. Okay, that's the idea. Let's just do two more quick ones. Let's go down here to 6 and 7. On 6, we have 655.45 millimeters of mercury, and they want us to get that into torr. Now you might be looking at that one with a slight frown saying, wait a second, those are the same. You're exactly right. 760 torr is 760 millimeters of mercury, so they're basically the same thing. And that way the units cancel. You don't even need your calculator here because the 760s cancel too, and that gives us 655.45 torr. Okay, so we didn't really need a calculator for that one because they're the same thing. All you'd really have to do is change the label, and I don't think that's math you'd ever have to show. But just to kind of get you the idea of how simple you can set these up, even when the numbers are obvious, it's easy to set them up. And on one like that, I wouldn't think you'd have to show it. Just cross the label out and change it to torr and call it good. The next one, the last one we'll do here, 2.25 atmospheres. We want to get that into torr. So again, we've used that equality statement earlier up on number 2. On number 2, we said 1 atmosphere was 760 torr. Now, of course, I'm putting it in here sort of upside down this time because I want my units to cancel out differently. So on the last question, number 2, we said that 1 atmosphere was equal to 760 torr, and we wrote it that way. Now on number 7, we're saying 1 atmosphere is still equal to 760 torr, except we're writing it the other way because that way, cancel out, atmospheres will be gone, and we'll have torr as our answer. So 2.25 times 760 divided by 1, you don't need to say that, answer 1710. And I can take that whole answer and run with it because it has 3 significant figures in it, just like my original number did. So that's pressure conversions back and forth. None of the others on this page are really any tougher than what you've seen in those 4 examples. Okay, so work on the rest of those. And then the last page is mass and volume units. So again, using units that you've almost certainly used since early grade school, but just to remind you about some of it and to put it back in front of you. It's amazing to me, and I'm not picking on you if this is you, because I would never want to do that, but it's amazing to me how many students struggle getting from liters to milliliters and back and forth again. Don't remember how many milliliters are in a liter. They know there's 1,000 in there somewhere maybe, but they don't know which way to do it. I don't even know how else to tell it to you if you're still struggling with that. That's why you need to practice them. So if it's obvious to you, all these are really super obvious to you, great. You either had someone teach it to you a way that just clicked really well with you, or you've practiced hard, or you're a natural metric learner, and you could very well live in Britain or something and do just fine. But as we're looking at units and conversions in our AP problems, a lot of times these are the points that I just assume you can do, and students will struggle with them. So that's why I'm putting it on here. early in the class and throughout, you're going to have to make conversions of these sorts, and they need to be automatic. Okay, you should still show the work, even though it's automatic. You're going to probably laugh and say, why do I have to show the work for that? I would still show it, because that way no one will ever wonder where you got your numbers from, and you'll always get full credit. It takes just a second or two to do a conversion that you just know the answer to, so it's worth the time. So some equalities for these that you probably know. Again, 1 liter is 1,000 milliliters. 1 kilogram is 1,000 grams. 1 gram is 1,000 milligrams. So there's our liters, milliliters, grams, milligrams, right? So grams is kind of the basic unit there, as is liters, and then milli has 1,000 of those. Milliliter, 1,000 milliliters in a liter, 1,000 milligrams in a gram. I think that's the only one that you'll need. There's some milligrams on here. So milligrams, 1 kilogram equals 1,000 grams, and there's 1,000 milligrams in each gram, so that's actually 1,000,000 then milligrams. Now, I don't think you'll ever, in a problem we'll do in class, have to go from kilograms to milligrams or back and forth between those. That's kind of silly. But just in case, it's here for you, just in case you need it. Okay. So let's take a look at some of these and use some of those conversions. 30.18 liters. I need to get to milliliters. Again, I'm going to use an equality that I know is true. 1,000 milliliters per liter. And that's from the list at the top of the page. Liters will cancel out if I set it up that way. And the answer, 30,180 milliliters. All right. You're literally just moving the decimal over 3 times on every problem on this page, or maybe 6 times if there's a milligrams to kilograms question. But always use your calculator. I mean, don't doubt the number just because you don't want to be the person pulling out your calculator. Don't get it wrong because you didn't want to take your calculator out and do it. If you can do them automatically, you're going to save a little time. If you can't, you can't. It's okay. I'd much rather you take a minute and do it right than get it wrong because you didn't want to pull your calculator out. 7,351 milliliters. 1 liter is 1,000 milliliters. So I'm dividing by 1,000 this time. Answer, 7.351 liters. And again, you can check them. 7,351 divided by 1,000, 7.351. You still got to label it. Make sure you label it at the end. Okay? Make sure you get those answers labeled. A number without a unit is pretty well worthless because it doesn't carry any kind of a meaning if you don't have a label behind it. Grams to milligrams, 33.67 grams. I need to get milligrams. That's one we don't use as much necessarily, but we'll see it here. So here's our grams to milligrams, 1,000 milligrams in a gram. So 1 gram is 1,000 milligrams. Taking it times 1,000 now, so 33,670 milligrams. This cancels out, right? So notice those units keep coming across. Liters became milliliters. Milliliters became liters. Grams became milligrams. Whatever unit is left there at the top right corner, almost every time, will be the label on your answer. There'll be some questions that we'll do later on where the units will be hiding elsewhere in the problem, but that's not today. Back the other way. I don't know if you need me to show you another one like that or not. Let's see if we can find anything else on here that's anything weirder than this. I think they're pretty much all going to be in that category. So, well, we'll do one more just so you have it. Okay, and then I'll let you be on this video. 26,050 milligrams. Convert those to grams. We need an equality statement to link them. We know 1 gram is equal to 1,000 milligrams. Just for purposes of kind of example, I want to make sure you understand why it matters where you put the numbers, right? If I do it like this, the milligrams will cancel and I'll be all set. But what if I didn't? Okay, what if I said 26,050 milligrams and then I came over here and said, well, I know 1 gram is equal to 1,000 milligrams. Because Mr. Bleth just said that a minute ago. And it's true. In fact, we used it just like that on the previous problem. So why isn't that okay? Well, because milligrams won't cancel with grams. This unit and this unit don't cancel each other. So if I punch this in my calculator, I'd get an answer, and my units would be like milligrams squared per gram, and that doesn't make any sense at all. You can't have a squared mass. It doesn't work. So we're going to take that off. We're going to use the units the way we originally had them set up. 26,050 milligrams. Those units should always come down and away so they cancel out. They should be diagonal so they cancel out. And then I know the truth still works. 1,000 milligrams is 1 gram, and now the units will cancel out. Okay, so the answer there, 26.05 grams. Back and forth between kilograms and grams, going to happen often. Back and forth between grams and milligrams, not real common, but somewhat. And then certainly milliliters and liters all the time. We're going to use that one all the time. So just get used to when to put 1,000 next to what. You got to get a sense in your head of what's smaller, right? It's going to take 1,000 little milliliters to make a big liter. A water bottle might be a liter. A milliliter is like, the size of your pinky tip. Not even, that's probably a couple milliliters. So as we're looking at volumes, your pinky is like 2 milliliters. Your pinky tip is 2 milliliters or 3. And a liter bottle is huge. So 1 liter, big. 1 milliliter, tiny. It takes 1,000 of those to make a big liter. Get something in your head that makes that connect. Okay. Work on the rest of these. I'll post an answer key and make it available to you, and you can check them then. Thanks.